everybody. Welcome to Skype a Scientist Live. We're so happy to have you here with us. Today, we're joined by Sydney Dolan. We're going to be talking about missions to the moon and Mars, which I am pumped about. So, housekeeping. Tomorrow, Skype a Scientist is taking the day to participate in something called Shut Down STEM or Shut Down Academia. We're going to basically be taking the day to do some reading and planning with specific things that we're going to do to make sure that our program is running in a way that supports Black scientists, Black science communicators in the best way that we can, and make sure that we're also helping academics improve their departments and generally supporting making the world better, because we have work to do and we all do. So if you are a scientist, we'd love to hear if you're participating in that as well. That would be great. We know it's mostly kids today, which is understandable. Other things happening on Thursday at 1 p.m. We're going to be talking about space fireworks. So that's like when things in space collide and you get these like things that look like fireworks with Tomas. We're going to be talking all about that. And then on Friday, we're talking with Riley Black, who's a science writer, all about, alternate, not just careers in science that have you like moving liquids around, like that being a science communicator as a science writer is a super important job. And she is so good at it and has had a really successful career. So we'll be talking with her. There's also things going on all next week, but that is all the stuff we have to talk about today. We hope that you're taking this week, just like we've said every day for the last 2 weeks, really thinking hard about how we can be better and more supportive of Black folks in our communities, in our institutions, in our lives, and thinking about specific actions that we can take, and not just making the social media posts, really focusing on action. And not just talking about it. So that's it for me. Let's introduce our guest today, Sydney.
Yeah, hi. My name is Sydney Dolan. I'm a graduate student at MIT in the Engineering Systems Lab, and I study crewed missions to the moon and Mars. What got me interested in aerospace at first, I was really lucky in high school to join a model rocketry club. And that experience of building rockets and making those trajectories convinced me I was smart enough to go do some rocket science. And so ever since then, I've just been learning more and more about space. And it's an awesome field.
That's amazing. So yeah, we already have questions coming in. So the first question is going to be from Gavin. How close is the Martian movie to real Mars?
So in many ways, they did such a good job bringing consultants in, and one of my close friends is actually the astrophysicist consultant for Disney. So they've been doing more of a concerted effort to make these movies more accurate to real life. So the Martian surface is very accurate to what you would see. I think you've seen the photos from the mole mission with the Martian drill. The characteristics of the soil and such are accurate. Some of the issues with the broader scheme of things, I think the ascent to the surface that Mark Watney used, at the risk of spoiling it, is a little ambitious for the level of forces that a human can take, as well as the heating that a person can take. So I think the re-entry gimmicks there would not pass a sanity check. But in terms of the fact that they sent go ahead of time and had this huge base built up, these are a common aspects in a lot of the features that NASA is considering for these broad plans to build up like a base on Mars.
Awesome. The next question is, when do you think people might go to Mars?
So there's a physics answer to this, and then a personal answer to this.
Great.
The way the physics works with windows to go to Mars, technically we can go whenever, but there are times where it is more fuel efficient to go. And those windows happen about every 2.5 years.
Oh.
And so the current rover, Mars 2020, which I think is now called Perseverance, was supposed to go in 2018, but we didn't have all the science right then, so it got pushed a little bit. Um, so roughly every 2.5 years we could go, but technically, there's still a lot of scientific issues that need to be cleared up before NASA would be comfortable sending people. So I think that estimate of early 2030s is a lot more realistic. I love reading into like the bioastronautics, and like we still don't have a lot of solved issues, particularly the radiation a duration of
Yeah.
that speed. And for like the Apollo mission, they were 1 week away from being hit by like a huge radioactive event, and that would have killed them immediately if the Apollo 13 mission had happened at that time. And we still have level protection if something like that was to occur on a mission to Mars. So that's just like one example of something that needs to be explored and mitigated further before we be comfortable sending people far into space with, a lot of effort to take to rescue, as you would see in The Martian.
Wow, wild. Okay, so I'm a squid biologist. I don't know much about physics or like what the heck is going on in space broadly. So like what would like okay, first of all, what does a radioactive like event like look like and where is it coming from and like can you predict when those things are going to happen?
So this is a little bit on the edge of my knowledge, so I'll
That's
try to
okay. If you don't
explain it
know,
at a
like,
base level.
not enough.
The radioactive events from solar flares from the sun. So I think you've seen those like videos, or the sun has that almost like volcanic eruption,
Yeah,
and
totally.
then that radiation propagates to the earth, and we're safe on the earth because we have the atmosphere to break it down. And so that's why it's not an issue down here. There's nothing to protect astronauts. So there's different levels of, I think, like alpha, beta, and gamma radiation. And there's also standards to what we're comfortable exposing astronauts to. And I think the unit is sieverts. And so this is also used in like x-rays and cancer radiation. There's, I think, as you know, with Mary Curie, there's a level of radiation we're comfortable exposing people to, and past that, we don't want to put their health at risk. And so if you were to be hit by the radioactive event, for satellites that are out in space, it essentially just fries the electronics.
Ooh,
Um, it would not you would not see it physically, but it would it would be affecting your cells on a molecular level and lead you to a much higher risk of cancer.
wild. Yeah, I read a couple months ago this book, Radium Girls. It's about this group of painters in New Jersey, I want to say in the 50s, that were painting watch faces that like were glow in the dark, and they had radium in them. And wow, what a horrible thing. Basically, it just totally melted their faces, and it's just awful. So yeah, we definitely don't want to do that to astronauts. So but let's go on to some other different questions from our audience here. Arjun would like to know, what's the moon made of?
Um, so I'm not super into planetary science, so I can't talk about the composition of the moon too much. I can mainly talk about plans to get there, and then we
Great.
go to really smart scientists that study that in a lot more detail than I do.
No worries. You can always say, I don't know, because one thing that I think is it's good to communicate, particularly to kids, is that like scientists don't know everything. And even if I know a lot about squid, if you ask me a question about whales, I'm not going to know. And that's okay. That's like a very important thing to communicate. So that's no shame in saying I don't know. So here's a question. How long would it take us to get to Mars? Like we're in the rocket sitting on Earth, we leave. How long is it going to take us to get there?
That is actually a very complicated question related to the mission plan that we'll take to go to Mars.
Uh-huh.
So when we're planning a mission to another planet, it's a lot like planning a vacation with your family.
Uh-huh.
So first you got to decide where to go. And so that may seem easy of like, oh, we're going to Mars, but
Right.
there's icier regions of Mars, there's volcanic regions of Mars. So we would need to consult with those planetary scientists that know a lot more about what would be scientifically valuable and also a safe area to explore. And then also, just like vacations, you got to figure out what to pack and where you're stopping along the way.
Yeah.
And so, depending on those elements of how much is sent ahead of time cargo-wise. If there's going to be fuel refueling on the surface, that means the spacecraft that the astronauts are traveling in can be smaller and thus like could go faster, or would not need as many engines to really like push it to be faster. So those decisions of like where you're going to stop and what you're bringing make a huge impact. I think the fastest time, if we were to think that's the most important priority in the design, is around I think 8 months to get to Mars. But if you were to say, oh, we're not going to prioritize that, instead, you know, maybe we'll enjoy the view and we want to save some fuel, which saves us money, the journey can be years. So and that also goes back to what windows you choose at the start, just for Earth and Mars to line up in their respective orbits.
Right. Wow, that's amazing. So are you saying that we are thinking about like making gas stations along the way?
Yeah.
Oh.
Yeah, it's super exciting. There's two things if you want to look into it further. NASA has a program. They rename it every few years, but it's called Gateway. And what they want to do is, if you're not familiar with rocket launches, rockets are staged. So they'll drop the useless parts of the rocket that they've used all the fuel up at each point. So a rocket that would be going to the moon or Mars would have at least 3 stages. And what NASA is considering is that second stage, which is typically dropped off in low Earth orbit. They want to repurpose those to be used as gas stations. So they would get space robots to go in and they would bring the fuel, they would go and seal it, make it vacuum tight, and then satellites that were low on fuel could dock with it and refuel, and that would extend the lifetime of them much further, because for satellites that don't have any malfunctioning errors, fuel is the limiting factor in lifetime.
Wow, I had no idea. That's
Yeah.
so cool. All right, do you have anything to do with like the Mars rover missions?
No, not really. I apologize.
I apologize. That's fine. Your job is awesome. We're just a lot of times we think of like space missions like everybody knows everybody else, and there are so many people working on space that yeah, we're all learning how that all works. Let's see. So, which has more volcanoes? And it's okay if you don't know this. Do you think it's going to be Earth or Mars?
I don't know this. I just know that Mars has much
Yeah.
larger volcanoes with Olympus Mons.
Oh, I didn't know that. Cool. All right, sounds good. Do we have any idea if there's life on Mars?
So this is a complicated question. So we have definitive evidence that there is water on Mars and ice, and that could be extremely useful to us. One, because that could be life, but it also could be used for fuel when we land to Mars. So that goes back to, you know, saving mass. We also, with like the drill, the mole that they put up in 2018, have been looking deeper into the surface because we don't know the composition, and if we understand the lifetime of the planet better, we can see if it was maybe more habitable in the past. I know I've done a little bit of research on stromatolites, which is a type of rock formation that you would typically see in like riverbeds, and it's indicative that there was life on there at one point, but at this point with current knowledge we cannot definitively prove that there is life on Mars right now.
Awesome. Just to like give a sense of the connectiveness of science. So I'm a squid biologist, and my buddy squid biologist studies the bacteria that live in squid, and she also studies stromatolites, and you studied stromatolites. So like we're all connected. How lovely is that? The next question is, will astronauts live in buildings on Mars, or will they just live in their rocket ship?
So that is dealer's choice. I'm sorry that we don't have like a defined plan for what could happen, but there are a lot of really exciting ideas of what a Mars base would look like. And so one of the things they're thinking about the most would be that it would be inflatable. And so you could almost imagine it like a bounce house that they would set up on Mars and live in. And that's just because if we were to build houses in the sense that we do on Earth, that's just too much material and too much like technical rigor if we were to make robots do all of that. Whereas the inflatables are much lighter and can provide much more space. So a lot of the designs for Martian habitats involve these like huge inflatables that the astronauts would live in, but it's also possible if some of the missions I've looked at only have like 2 week stays at the surface. And so if a mission was that short, they would not be going through all the effort to build this huge camp when the astronauts could slum it in the in their rocket for a little bit.
So if astronauts go to Mars, are they going to be able to come back home?
Yes. This is 100%. We're not sending anyone to the Mars or Moon unless they're coming back, please. That is, I think that was, some people wanted a one-way ticket. That is not happening. People will be coming back.
Oh, good. Yeah, that would be so scary. I don't want to leave Earth at all. I want to stay close to sea level. Whew, it spooks me out. The next question is, how long do we think it would take to get from here to the moon? We've done it before. Is it the same as before? Or are we faster than we used to be or anything like that?
It is about the same as before of like the few days venture to get there and then catch into the lunar orbit and then go to the surface. I think the biggest difference between what we're considering now and Apollo is that they want to set up the infrastructure so we can have astronauts on the moon for much longer term. And so some of the decisions that they're looking at now factor in how easy it would be to rescue the astronauts at any point if for some reason they needed help and they were there for several months, just like there are astronauts in the International Space Station that are there for 6 months at a time.
Right. Wow. If you personally had the choice, this is from Teddy, age 10, to go to the moon or Mars, which would you pick?
Oh, I'll go to the moon. It's so much closer. I don't think I have the grit to take that 2-year journey to Mars. I applaud the people that really want to, but I would like to be back to Earth at some point, and I think the moon is so cool, and I'm very excited that we're going back soon.
That's awesome. But so generally speaking, if you were given the chance, like your options would be like stay in the lab or go to the moon, you would go to the moon?
Oh yeah.
That's awesome. Let's see. This is from Jenny. What would you say to a young person debating whether to pursue an astro career?
I think the most important thing for whether you should pursue an astro career is whether or not you love space. And if you love space, you deserve to be here. You should throw away any notion that rocket science is for geniuses or whatever. If you love space, like, there are people here to help you if you're struggling with something. It is such a fun place to be. It's more than just doing math and coding. Like you said, there's stromatolites. You can do astrobiology. You can be working in space medicine. That's a super important field. Like, there's so much opportunity here. It's such exciting work. I mean, like, sending something to space. So just have faith in yourself that if this is something you're interested in, like, you have all the skills to crush it, and you're totally welcome here.
Awesome. That's a great answer. The next question is from Sana. Is it possible to go to Venus? Because we're always focusing on Mars. Like, is Venus even an option?
So Venus is an option, but it would be very difficult. There's actually some really interesting studies that I've read on, since Venus's atmosphere is so thick, going into Venus, we would probably need to use like a blimp-like setup to go around, just because the fumes are so toxic, and we don't have the strongest characterization of what the surface is like. So blimps would be the way to go, I think, just because of the amount of similarities that are shared with Earth. That's why Mars has been a priority. But there definitely are stuff in the works from the NASA Jet Propulsion Lab about more probes to explore Venus.
Cool. That sounds super fun. Charlotte would like to know, will civilians be able to live on Mars at some point?
I mean, that's the dream, isn't it? It's not, coming in the next 3 years or so. It's definitely further down the line, but the hope is that by setting up this infrastructure both on the moon and Mars, people will be able to go to these places and have that accessibility the same level that you would, going onto the internet and doing whatever you want there, of just going up to low Earth orbit for a day. Super exciting.
Yeah. Awesome. So do we know, is NASA like long-term planning to establish a permanent settlement on Mars, like the International Space Station, but on Mars?
NASA does not have finalized plans for what they want to do on Mars. Their current published mission architecture, if for just the first time they're going to Mars, is called the Design Reference Manual 5. It's a very long document if you need some nighttime reading. And the gist of it is that we would send cargo ahead of time. We would go for at least a year, and then we would come back.
Cool. Sounds good. Next question. Did you always know that you wanted to be a scientist when you were growing up?
I did not know I wanted to do rocket science until I had that formative experience with model rocketry. I did not think I was smart enough. I was lucky enough to be in advanced math classes, but I was not the top student, and I didn't think, since I wasn't the one that was like, oh, I got it, I know how division works, like, I didn't think it was the field for me. But having that hands-on experience of being able to build a rocket and then see it launch, it was just so confidence inspiring to be like, wow, I built that, like, that's something I do. And also having really good mentors that were like, hey, you're good at this, like, you like this, you should do this in the field. That's incredibly important.
Yeah, mentorship is essential, for sure. So what does like a standard day in your job look like?
Yeah. So because I'm a grad student, what that means is that I'm taking classes so I can learn more about the field and how to perform research better. And then I'm also doing my own research as well. So for classes, I will take a lot of math and coding based classes. So I'm developing those skills to be able to do that really complicated math about how we go to the moon and Mars. And then for my research, that involves doing a lot of literature reviews and reading. I was not born with all of this knowledge. It comes from just reading a lot and then going through and seeing what those authors read and trying to get a better understanding of what's been done and what's been avoided so we can make meaningful work in the future. And then once that literature review is completed, I go through and try to make my own models. So my lab did a study this past fall on the current plan is we'll go to the moon and then go to Mars. And so we looked at technologies that you could use on the moon first and see how useful those would be on Mars to see if there was any recommendations that we could provide to NASA and commercial companies.
Very cool. That's awesome. So the next question is, as scientists, what do you do in your spare time?
Yeah. So I'm in Colorado for the summer for my fellowship, and so I've been running a lot. It's really pretty. I also like rock climbing and baking. I'm not a good baker. I think everybody in quarantine's been like making very pretty things, and I've just been finding all the gross recipes and then forcing them on my friends.
Sounds good. If I was your friend, I'd appreciate it because I'll take any food, not picky. Let's see. The next question is, what is your favorite planet?
Well, before it was not a planet. I was quite a fan of Pluto, but that's not the correct answer anymore.
Yeah.
So I think my favorite planet now would be Mars.
Sounds good. The next question is, are rovers and satellites launched the same way as we launch humans?
Um, so are they launched in the sense that we use a rocket to send them up? Yes, on that level, it is the same thing. But the compartments we put them in are a little different. And so for people, we'll put them in a capsule, and that's different because it has AC, they can breathe. It's, they have some really nice chairs. I've sat in them, quite nice.
Cool.
They have lights and all the stuff to do steering. Whereas for satellites, they don't have the brain power like us. They're not piloting the spacecraft. And so those are almost a lot more like storage containers you would see. And stuff is, there's the main payload, which is probably the most expensive or most scientifically valuable one that's put in. And then anything else that can fit is kind of like crammed around. So it's like when you're moving out of your house, or you have to organize your closet, and you have the one big item, and then you're like, how much else can we throw in here?
Right. Yeah.
That first thing takes priority, but whatever else can fit and also wants to be in whatever orbit that it's going to, they try to cram as much in as they can.
Sounds good. Jenny would like to know, do you think that humans will step on Mars in your lifetime?
Yes, I have full faith that it's happening. I think, I'm putting in the work to make it happen. There's so many smart people at NASA and all these companies passionate about this. I think it will happen.
Love that. Have optimism. We'll hope we'll get there. The next question is, have you ever been to the ISS?
No, sadly, I am not an astronaut. So to be an astronaut, you need to have typically either be a pilot. So you've gone to pilot training and done a certain amount of hours, or a lot of the astronaut requirements require a graduate degree, which is when you go to college, you first do your bachelor's. And then if you want to learn a bit more, that's what a graduate degree is. And so I have to finish getting mine before I will be eligible to be an astronaut.
Wow, sounds good. That's a high bar for people going to space. That's amazing. The next question is, when people have historically gone to the moon, would they just sleep on the spaceship?
Yeah.
Yeah.
So for sleep and body functions, for when astronauts go to space, NASA is actually regimenting their diet in the weeks leading up to it. And so you won't have to poop as much because they've essentially like clogged your system up. But
Oh my God.
on the sleep issue, you're sleeping in the capsule or the lander. For the capsule they most commonly use nowadays, it's pretty much you're just like almost in like a fetal position curled up, and it's like that for 2 days until you get to the space station. It is not the most comfortable of positions.
Wow, that sounds, people really, really, really want to have to go to space to put up with that, but that's great that someone else wants to do it. That's wild. So let's see. Bella says, I seriously want to be an astronaut when I grow up. Did you know that you wanted to go into your field when you were in high school? And then what did you do to get to where you are?
So I started to figure out that I liked aerospace engineering in high school. I think the classes that were most helpful for me, and this is also, I was very lucky to have a high school that had advanced math classes and calculus and linear algebra. The most helpful one was AP physics classes. And I think it was so funny because the first time I took it, I was like, oh, I'm not going to do like this type. Like I only liked some parts of it, and I was like, oh, I'm never going to do rotational physics, or I'm never going to do this part. I'm only going to do the parts I like. And it's ended up being that I've used all of it, and it's a lot less painful than the first time I've learned it. So if I would try to take as many math classes or physics classes as you have available at your high school, and also to plug MIT. All of MIT's college courses are available for free online, so you can watch the lectures and work along with them if you are really a go-getter and want to get after it. Some other things I think were super helpful. You can look to see if there's a model rocketry club somewhere in your vicinity. If you are in the inner city, there are rules about launching rockets in a city for safety, so it's definitely easier accessibility wise if you're maybe more in a rural area or can drive to, you know, farmland where there's not as much of a risk of a rocket being hit. There's also like amazing programs you can get to learn. I think Kerbal Space Program is one of the free ones online, and that one, I think almost everybody I know has like played with it a ton. They have all these amazing features to set up spaceships, and it gives you a really good sense of orbital mechanics and how to design those trajectories to other planets. So I would recommend looking into that. Hopefully that was helpful.
Awesome. That's a lot of cool stuff to check out. Totally. The next question is, how long does it take to build a space rocket?
So it depends on the size and whether it's the first time you're doing it. So if it is a smaller rocket that is designed to make CubeSats, so CubeSats are like about 6 inches by 6 inches, that type of rocket can be made in a matter of weeks if you've built it before. If you're talking about the rockets that people are in, that's a lot more complicated because we really want to make sure that astronauts are safe. So everything is checked and tested rigorously. So every part you see on a rocket like the Falcon 9 that launched people last week, every component has been checked multiple times. They check the failure rate, they check like per, you know, 10,000 iterations. So that process of making sure nothing's going to break is very time consuming, and thus it can take, I think, around 20 years to make a rocket on the scale of one that would be launching people or really big spacecraft like the Mars rovers.
Wow, that's wild. The next question is, how much of the flight do astronauts in the ship actually have to control as opposed to kind of machines programmed to do it for them?
So it's getting to be less and less, which is really exciting that we have the computational skill to do it faster and faster. So for example, the crewed launch that happened last week with the astronauts going to the space station, they did not have to control anything with the docking. It was entirely autonomous. The robots did everything. For the most part, for ascent and descent, for current systems, there's not much piloting required, and they're mainly just looking at the panels to make sure everything is operating nominally, and if it is, they don't really get involved. They just let the spacecraft do what it is. For a spacecraft like the space shuttle, which was a plane, that took a lot more piloting, and they would need to be in simulations for thousands of hours to learn how to steer and get a sense of what the rocket would feel like as it was re-entering.
Wow, that's really cool. Last week, actually, we had somebody who worked on the like connection between the rocket that went up in the ISS, which was so cool. Aaron Eldridge, which was like, so cool. This is also really so cool. Let's see. So we've got a couple of questions that you may not know the answer to, and if not, that's totally cool. Just we're gonna throw them out there and see what happens. Do you know why our galaxy is named the Milky Way?
No, I'm sorry, I apologize. That's out of my...
No idea why it's called the Milky Way. And I don't know what came first, the candy bar or the name of our... I don't know that either. The next question is from Trey, age 10, and Yaya, age 13. What's Pluto made of? Do we know? Is it just rocks?
I do not know, but I think we got a better sense from the New Horizons mission when it flew by. So
I know what it looks like.
Look into that.
I don't know what it's made of. I know it got a big heart on it, which is just adorable. The next question is, do the boosters how do the boosters get to the pads to be reused?
Yeah, so that's a good question. So this is some like really exciting science that has only occurred in like the past few years. And so what happens is, for the staging, the rocket at a certain point will decide to drop off the lower part, and that's the part that's going to be reused that you would see in the videos. And so at that point of separation, it runs an initial calculation that says, I am at this altitude and I want to get back to this point on Earth. Here is a vague path that I think will take me there. And then it begins to follow that path towards reentry. And then at each point, it's iteratively recalculating to make sure it's still on track to actually land on that point, which is super exciting. And so what's made that such like a revolutionary technically like thing of merit is that if we were to solve at every point like, oh, it has to be perfect, we have to know everything, we have to be so confident, we wouldn't have computers that were fast enough to do that in real time. Whereas the way that they've been able to simplify it to land allows us to land with the level of fidelity you see on those, like, that's, you think we're coming from space, like the fact that we're landing on those tiny ships is just such an incredible accomplishment.
For real. The whole thing to me seems so unthinkably amazing. Like, I just can't believe we can do it. Like, knowing what I have in here, like how people do, it's amazing. The next question is, what kinds of food do you get when you're going on a mission to Mars? Like, what are they eating on the way when they get there? What's the deal?
So this is actually such an exciting thing to study, and there's a lot of work going on it at Johnson Space Center in Texas. So when you're in space, essentially in Earth, you can think about sometimes when you wake up, your nose is a little stuffy and you blow it and you know it's fine. In space, there's no gravity to push your sinuses down. So you're kind of a little clogged the whole time you're out. Not like painfully so, but your smell and taste is a little dull compared to what it would be here. And so the food isn't as good, but you don't taste as much.
Oh.
So what seems to be really popular in food with astronauts is actually spicy food. That's one of the tastes that you retain pretty well in space. And so people put a lot of hot sauce on a lot of the food they eat in space. And also NASA works with the astronauts so that they can bring a few home meals that aren't freeze dried and, you know, actually taste like real food. And so that is a good morale booster for them to have throughout. So for Mars, you would probably be eating more spicy food. And, you know, I know they have like dehydrated shrimp. That's one that one of my professors said it was his favorite. And then you would also be bringing, you know, maybe your favorite food that your mom makes.
Wow, that's awesome. I like have no tolerance for spicy food. I was raised on like potatoes basically. I don't know. That seems wild that I would like spicy food, but also if your taste buds don't work, of course, that's funny to think about. The next question, and I think it might be the last audience question we'll have time for. Let's see. I had one. Where is it? Actually, my question is going to be, are there any questions that you wish that we asked you?
No, I just wish we could get to them all. I hope if people have one thing to take away, it's that there's so much to do in space and you shouldn't be intimidated by it. There's so many ways to contribute of being a planetary scientist. So you can tell me more about how Pluto and Moon and what Mars is made of, or doing what I do and planning missions to Mars. I just hope that it's made space seem less intimidating and that you want to keep on going into the field.
For sure. Yeah. Okay. So we asked everybody the same two questions at the end. And the first question is, what's something that you wish everybody knew about your area of expertise? And the second question is, what is something that you wish everybody in the world knew about literally anything? It can be as simple and silly or big and significant as you'd like.
Okay. One thing I wish everyone knew about space is how much it helps other fields as well. There's a lot of transfer technologies that we've gotten from sending people to space that help you every day on Earth. LASIK surgery to make your eyes 20/20 actually comes from the science that we've done in space to help astronauts see all right. Yeah, there's just so many things that have transferred from how we've learned to take care of people better in space, especially in like the medical field. And so if you ever encounter someone that may not get why it's cool to go to the moon or Mars. There's a lot of benefits that come to learning how our bodies work and how we could function better up there, and also just scientifically of like vacuum pumps and stuff have transferred from being space rated to being used day to day on Earth, and I think that's just incredible.
That is totally incredible.
And then, oh yeah, sorry.
The like about literally anything question.
Well, this is actually my favorite space fact. I just think it's the wildest thing. So Russia and America have very different design styles when it comes to space, and Americans will really like tailor and potentially like over design things perfectly, whereas Russia will find something that works and then just force everything to make it work with that one item. And so my favorite example is that for deploying satellites from the ISS, the Americans have essentially like this spring launcher which controls the like angle and make sure it's at this like perfect distance, and it's like rigorously done so that, you know, the spacecraft won't tumble, and it's very, very meticulous. And the Russians actually will suit up in their in their spacesuits and go outside the ISS, and they have an informal record, and they throw the satellites to deploy them, which is incredibly dangerous. But it's also one of the coolest things I've ever heard of, that for some of the satellites where they're smaller, they will literally just, and there's astronauts, there's one, I forget, cosmonaut that has the informal record for furthest and like fastest throw from the ISS.
That's amazing. Also, who doesn't want to just like whip a satellite? That sounds more fun. Okay, I always have said I don't want to go to space, but if I got to whip a satellite, that sounds pretty fun. That might be like the thing that makes me think like, fine, I'll do it. That's awesome. Thanks so much for taking the time to talk with us today. This was really, really cool. So is there anything that you'd like to plug? And also tell us where we can find you online to learn more.
So I have a website, so if I didn't get to your question, it's my full name, sydneyidolan.com. That's also my email at Gmail if you like. I really want to get to everybody's questions if you still have it. I'm also pretty active on Twitter. My handle was my high school nickname, so it's Syndam, SYNDAMN.
Great. Cool. Well, thank you again for the time that you took to talk to us. I learned so much, and it's just like so cool. Space is something that I know, all I know about space, I've learned from running Skype a Scientist live sessions, which is great. Erin, thank you for signing with us. Always appreciated. And we'll see you back here on Thursday to talk about space fireworks, and then Friday to talk about science writing, both happening at 1 p.m. Eastern. Let me confirm that that's true. I think so. Well, it's in the email. Let me just make absolutely sure that I'm telling you the right time. 1 second. 1 p.m. 1 p.m. Yep, both at 1 p.m. Eastern. Thank you again for taking the time, and we'll see y'all later this week. Bye.